Hello everyone, my name is Pino. In this video we go through the following question, which is based on arithmetic pattern, and we consider the linear pattern. So the linear part is just another way of saying arithmetic. So we consider the arithmetic pattern with 5 as the first term and 7 as the second term and 9 as the third term. And question 4.1, we determine the value of term number 51. So term number 51 is the unknown, and for an arithmetic pattern or a linear pattern, we have Tn is equals to a plus n minus 1 multiplied by the common difference d, and the a is equals to the first term or term number 1, which is equals to 5 in our case, and the d is the common difference. Remember that we have to determine term number 51. So our n is equals to 51. So we have Tn is equals to a, but in the place of the a, we are going to substitute the first term, which is equals to 5 plus n minus 1 multiplied by the common difference d. So let's determine the common difference. The 7 minus 5 will be equals to 2, and the 9 minus 7 is also equals to 2. So in the place of the d, we substitute 2. Our Tn, so we try to simplify, our Tn will be equals to 5 plus, we distributed the 2 inside the parentheses, so 2 multiplied by n will be equals to 2n, and 2 multiplied by negative 1 is equals to negative 2. Our Tn will be equals to, so the 5 minus the 2 will be equals to positive 3 plus the 2n. So now where there is n, we are going to substitute 51. So to determine term number 51, we substitute 51 where there is the n, and the term number 51 will be equals to the 2 multiplied by 51 is equals to 102, and the 102 plus 3 will be equals to 105. So term number 51 is equal to 105. And now, question 4.2, we calculate the sum of the first 51 terms. So since this is an arithmetic pattern, sum to 51 terms will be equals to n divided by 2 into 2 multiplied by a plus n minus 1 multiplied by d, and the sum to 51 terms. So this was supposed to be 51 and not 21. So the sum to 51 terms will be equals to, in the place of the n, we substitute 51, and this will be divided by the 2 into 2 multiplied by a, and the a, the first term, is equals to 5, plus, in the place of the n, we have 51 minus 1 multiplied by the common difference, which is 2, so the sum to 51 terms will be equals to the sum to 51 terms will be equals to 2,805. We move on to question 4.3, where we write down the expansion of the sum of 2n plus 3 from n is equals to 1 up until 5,000, and we only show the first 3 terms and the last term of the expansion. So we have the sum will end at 5,000, and it will start at n is equals to 1, and this is the sum of 2n plus 3. So let's copy this. To determine the expansion of the first 3 terms and the last term, we start by substituting n is equals to 1 where there is n. So where there is n, we are going to substitute 1. So we have 2 into 1 plus 3. And the next term after 1 is 2. So in the place of the n, we now substitute 2. So we have 2 into 2 plus 3. And for the next term, the next number after 2 is 3. So in the place of the n, we substitute 3. So we have 2 into 3 plus 3. And we also have to determine. So the instruction was that we show only the first 3 terms and the last term of the expansion, and the last term will occur when the n is equals to 5,000. So for the last term, in the place of the n, we substitute 5,000. So we have 2 into 5,000 plus 3. So 2 multiplied by 1 will be 2, plus 3 will be equals to 5. So the first term is equals to 5. And for the second term, we have 2 multiplied by 2, which is 4. 4 plus 3 is equals to 7. So we have 7 as the second term. And for the third term, 2 multiplied by 3 is equals to 6. And 6 plus 6 is equals to 9. And the last term, we have 2 multiplied by 5,000, which will be 10,000, plus 3, this will be 10,003. So we have the first, the second, and the third, and the last term. And for question 4.4, hence or otherwise calculate the sum of 2n plus 3 from n is equals to 1 up until 5,000, and we have to also add this to another sum of negative 2n minus 1 from n is equals to 1 up until 4,999. The Tn that we just determined, the Tn is equals to 3 plus 2n. We can notice that is the same as the Tn that is inside the summation. Inside the summation, we have Tn is equals to 2n plus 3, which is just the same as the Tn is equals to 3 plus 2n. By determining the summation of the Tn is equals to 3 plus 2n, we have determined the summation of the first sum. So the first sum is from n is equals to 1, and this is the sum of 2n plus 3 or 3 plus 2n up until n is equals to 5,000. There are two summations. We first determine the first one, and we will add this to the other summation which we will determine later on. So for the first sum, we have the sum to n terms of this arithmetic as n divided by 2 into 2 multiplied by a plus n minus 1 multiplied by the common difference d. Our n starts exactly at 1 and it ends at 5,000. So the sum to 5,000 terms will be equals to 5,000 in the place of the n divided by 2 into 2 multiplied by, so the 2n plus 3 is just the same as the 3 plus 2n. So our a will be 5 and our d will also be 2. So in the place of the a, we substitute 5 plus, so we are supposed to have d there. Sorry about that. So in the place of the n, we substitute 5,000 minus 1 multiplied by 2 in the place of the d. So we have the sum to 5,000 terms, which will be equals to 25,020,000. And this was from the first sum, so we have to determine the second part, and we will add the 2 since we have a positive in the middle. So that part we determined, and we will add to the second part. So let's determine the second summation. Allow me to clean the space. Remember that the Tn that we had inside the first summation was equal to the Tn that we determined using the 5, the 7, and the 9. But for the second part, the Tn is completely different. For the second part, we are going to determine the first term, the second, and the third using the Tn which is located inside the summation. So the Tn of the second part is equals to the negative 2n minus 1. So in determining term number 1, where there is n, we substitute 1, and the negative 2 multiplied by 1 will be negative 2 minus 1, and this will be equals to negative 3. And for term number 2, where there is n, we substitute 2. So negative 2 multiplied by 2 will be equal to negative 4, minus 1 will be equal to negative 5. Term number 3, in the place of the n, we substitute 3, so we have negative 2 into 3 minus 1, and this will be equals to negative 2 multiplied by 3 will be equals to negative 6 minus 1 is equals to negative 7. We now have the first term as negative 3 and the second term as negative 5 and the third term as a negative 7. And the common difference. Negative 5 minus 3 will be equals to negative 2, and minus 7 minus 5 will also be equals to negative 2. So the sum to n terms of the arithmetic, n divided by 2 into 2 multiplied by a plus n minus 1 multiplied by the common difference. So we are looking for the sum to 494,999. So we started at 1 exactly, and we have to determine to 4,999. So the sum to 4,999 will be equals to 4,999 divided by 2 into, in the place of the a, we have that negative 3. So negative 3 in the place of the a, and in the place of the n, we have 4,999 minus 1 into the common difference, negative 2. So in the place of the d, we substitute negative 2. And our sum to 4,999 will be equals to negative 24,999,999. Finally, we add the two sums. So we have a positive sign in the middle. So we are going to add the two sums. So we are going to add the first sum that we determined. We are going to add it to the second sum that we just determined. So the first sum to 5,000 terms we determined to be 25,020,000. So we add the sum to 5,000 terms because in the middle there we had a positive sign. We add this to the sum to 4,999, and the first sum was 25,020,000. and we add these to the sum to 4,999, then negative 24 million, and unfortunately I tried to pronounce that and I couldn't, so we just add the two using our calculator. And this will be equals to 20,001. Thank you guys for watching. If you have any questions, you can drop them in the comment section below. Remember to subscribe, like, and share this channel if you find this content useful.